I'm going to do a really quick run through climate change. It's not an easy topic, nor is it a new topic. I'd say the conventional view is much more common than the contrarian view. If you have a contrarian view, you think more people are like you than they are, and if you have the conventional view, you think you're more isolated than you are. In surveys, people are more confident in their contrarian views than their conventional views. We need to go beyond the damage report. Denial and despair have this in common: you haven't got to do anything. This is the worrying bit. These are the futures we're talking about. It is foolish to talk about adaptation on EP at 4 to 5 degrees warmer temperature. This is a challenge. This is our global emissions of CO2. It's at 40 million tonnes, 40 billion tonnes, gigatons, and we have to reduce it to 0 by 2050, which is the goal. And if we were to do that, we get this 1.5, 1.8 degree warming, and that gives us a challenge on EP of risk management. If we reduce it more slowly, so we plateau it more slowly, we're talking about disruption. If we go here, I think we're talking about a different planet and something completely different. And that's a problem for everyone. A warmer world is a wetter world, except where you chose to buy or inherit a farm. Okay, so basically in the mid latitudes, in these areas here, are the drying areas. These are climate stripes. So this is just a way that people use to explain warming, okay? This is for temperature change around the world, and you can see things are warming. This box is Eyre Peninsula. You can see there are climate stripes. Don't look at the numbers, just look at the stripes, okay? We can see that things are warming. This is every decade from 1911 through to now. So the last 2 decades have also been drier. The summer rainfall has politely helped us, okay? So there we're seeing a wetting in summer. This is what we've done running APSIM through all those years, and you can see the APSIM using CO2 as constant is pretty similar to the rainfall. If we increase the CO2 from 296 to 412 over that time, you can see, especially on Eyre Peninsula, if you go to Cummins, that goes to minus 6.6, it goes to positive 6.3. You've flipped the sign of your yield in that decade by adding the CO2 across that time. Plants will grow better with CO2. So farmers on EP that say, I'm not so sure about this climate change caper, this has no technology in it. This is just growing wheat with the same technology over the time. When you add technology to it, you would get an even stronger increase there. These are the 8 models that CSIRO uses to sort of bookend the problem, and we've used in this paper. But this is 2030, 2050, 2090, low emissions, high emissions. This basically tells us the story that if we have high emissions, 8.5, by the end of the century, we're in big trouble. If we have lower emissions, we're likely to be in less trouble. This is rainfall, and what this is showing, these are the same 8 models. There's this model here, which is the American model, the GFDL model, and it shows this sort of brown is minus 22% in 2030, 2050, 2090, irrespective of emissions almost. But you can see there's more brown than green on these models, but not all of them show the same level of drying. So what we're saying basically is that the range of models is somewhere between a headwind and a gale that's going to just blow us off the park. So I'd say we're going to have warmer average temperatures, increased heat frequency, changes to frost frequency and intensity, low confidence in what's happening with that, changes to seasonal rainfall, moderate confidence. We can say it's reasonably high confidence that we would expect it to be drying over the winter period, but by how much? is less so. Change in the intensity of rainfall, elevated levels of CO2, very high confidence.